pi there. Find all integer solutions of 2x squared plus 2xy plus 5y squared equals 29. So before we solve this one, feel free to pause the video so that you may try this one first on your own. Okay, good. So let us start. So to solve this, we first take note that this expression out here, 2x squared plus 2xy plus 5y squared, can be expressed of the form. First take note that 2x squared out here can be split into x squared plus x squared, and 5y squared out here can be split into y squared plus 4y squared. You'll see later on why we did that. So we'll have here the quantity x squared plus 2xy plus the quantity y squared plus 4y squared. Then we combine or we group these terms together. So we'll have x squared plus 2xy plus y squared plus x squared plus 4y squared. Now take note that these terms out here, when combined, forms a perfect square trinomial. So we know that by factoring this factors into quantity x plus y squared plus x squared plus 4y squared. And again, this is equal to 29. So this is what we have so far. And why did we did that one? Why did we do that one? Well, observe that these three are perfect squares. So we have shown that 29 is equal to a sum of three perfect squares. So what now? Well, fortunately, take note that the only trio that would yield this, what I mean by trio is trio of perfect squares that would yield this one is 4, 9, and 16. Indeed, if we add 4, 9, and 16, we have here 4 plus 9 is 30. Then 13 plus 16 would give us 29. So indeed, this one is correct. This would only vary depending on the position of 4, 9, and 16. But the answer would yield the same. So we can have 9 plus 4 plus 16. And we know that by the commutative property of addition, it would still yield the same sum. So indeed, these three, or this trio, is the only trio that would yield this. And you can verify that one. You can try other possible values out here. I think it's not hard to see that the only possible one is this trio out here, 4, 9, and 16. So by permutation, note that 3 factorial is equal to 3 times 2 times 1, or 6. So technically, this tells us that there are only 6 ways of rearranging 4, 9, and 16. So we'll have 6 cases later on, since it's like x plus y squared out here can take the value of 4, 9, and 16. So we'll check all the possible cases later on. So specifically, these 6 ways are 4, 9, and 16. This one. Or it can be 4, 16, and 9. 9, 4, and 16. 9, 16, and 4. 16, 4, and 9. And 16, 9, and 4. So we'll explore these 6 ways or 6 cases to find all the possible integer solutions of our equation. So let's clear out some things that we don't need, and let's move this up here and these set out here. So let's start with the first case, this one. So we have x plus y squared equals 4, x squared equals 9, and 4y squared equals 16. So basically this one becomes 4, 9, this is 16. So that is the idea that we'll be doing in each cases. So starting with this one, first take note that let's focus first on these two. So if you take the radical or the square root in here, then we'll have x equals plus minus 3. For this next one, we start by dividing this by 4 to get y squared equals 4. Then get the square root both sides and we get y equals plus minus 2. So we now have a value for x and y in the first case. So we now use this one. So given these, we have x plus y squared is equal to, if we have the same sign for x and y, so that is 3 and negative, same sign. So 3 and 2, then negative 3 and negative 2. If we add these up, then we'll have 5, and this one will be negative 5. Get the square, and we'll have 25. If we take the different signs, the opposite signs, I will have negative 3, 2, and 3, negative 2. So if we add this up, this one will be negative 1, this one will be 1. So taking it to the square, we'll have 1. In either cases, observe that these two are not equal to this. So we say that for this first case, we have no solutions, unfortunately. Let's move on to the second case. So this time we have 4, 16, and 9. And we do the same process. So first, take the square root out here, and this will give us plus minus 4. For the next one, we divide 4, get y squared equals 9 over 4, then get the square root out here, and we'll have y equals plus minus 3 over 2. Now note that we can stop here already, since y equals plus minus 3 over 2 is not an integer, and again what we want are integers. So even if there is a solution out here, we don't consider it. So we say that for this case, we don't have solutions. To be specific, we don't have integer solution. So we don't have an outcome again for the second case. Let's move on to the third case. So we have 9, 4, and 16. 9, 4, and 16. So we do the same process. We get the square root out here, and that would give us x equals plus minus 2. For this one, we divide 4 first to get y squared equals 4. Get the square root out here, and we'll have y equals plus minus 2. So we now have a value for x and y. So we do the same thing. We focus now on x plus y squared. If we have the same sign, so that is 2 and 2, or negative 2 minus 2, then we'll have 4, get the square, and this would give us 16. If we choose the opposite signs, then we'll have, that would be 2 and negative 2. Sorry for that lag. So we have 2 and negative 2, then we have negative 2 and 2. If we add these up, the outcome will be 0. Get the square, and the outcome will still be 0. Again, in either cases, none of these match to 9. So we say again in this case that we have no solution. So far not good, since we're not getting anything actually. Let's try to check the fourth case. So we have x plus y squared equals 9, x squared equals 16, and 4y squared equals 4. So we chose the 9, 16, 4 case, 9, 16, and 4. So we do the same process, get the square root here, and we obtain x equals plus minus 4. Divide 4 here to get y squared equals 1. get the square root, and we'll obtain y equals plus minus 1. And let's try to observe what happens when we have x plus y squared. If we have same signs, then we have 4 and 1, negative 4 and negative 1. Add these up, we'll get 5, negative 5, take their squares, and we'll have 25. If we choose the opposite sign, then we'll have 4, negative 1, and negative 4 and 1. If we add these, we'll get 3, negative 3, and if we take the square, we'll get 9. Now observe here that one of the possible cases matches, 9 out here and 9. Again, this happens when 9, or when we choose x and y to be different signs or opposite signs. That is, we have a solution. More specifically, these are the pair 4, negative 1 and the pair negative 4, 1, or the pair with different signs. So for this case, our solution is 4, negative 1 and negative 4, 1. So we have now find a solution, two solutions for this one. So that's really nice, but take note that we aren't done yet, since we have two more cases. So we inspect that again, or we inspect that further. So for the fifth case, so we have 16, 4, and 9. And we do the same process. Get the square root out here. This would give us x equals plus minus 2. For the next case, we divide, or for the next one, this one, we divide 4 to get y squared equals 9 over 4. Get the square root, and we have this. Again, take note that y out here is not an integer. So for this case, since we want integer solutions, even though if there is an outcome out here, we don't consider it. So we have here no solution. And again, to be exact, no integer solution. Okay, so let's now move on to our last case. So let's go. This one is the last one. And yeah, let's do this. So we do the same step. Get the square root out here. This would give us x equals plus minus 3. Then for 4y squared equals 4, we divide 4 to get y squared equals 1. Get the square root, and we'll have y equals plus minus 1. Using these two, we now check x plus y squared. So if we choose the same sign, so that is 3 and 1, and negative 3 and negative 1, if we add these up, we'll have 4, negative 4, get the square, and we'll get 16. If we choose the opposite signs, then that would be 3, negative 1, and negative 3, 1. Add these up, and we'll have here 2, this one, negative 2. Take the square, and we'll get 4. Now observe here that one of these two matches what we want. So we have a possible solution. And again, this occurs out here, as we have seen earlier. This occurs when we have the same signs for x and y, or that is the ordered pair 3, 1 and negative 3, negative 1. So for this case, a solution or two solutions are the pair 3, 1 and the pair negative 3, negative 1. Since we have exhausted all the possible cases, we are done. And these set of solutions out here is the final answer. So I hope you got that one correctly. It's quite a lengthy process since there are a lot of cases. But once we are done, it's good. So yeah, I hope you enjoyed and learned a lot from this one. Feel free to pause or feel free to comment down below if you have any comments, suggestions, and recommendations for this video, this type of video, and the channel in general. So that's it, and that's all for this how to solve video.